In this question, what we're asked to do is make it possible to have a car class. I'm going to say here class car. And I don't really care about anything else in the car. But I should be able to say, I'm just going to say pass for now, even though we're going to have to fill it in. I should be able to say c equals a car. We're going to have a new car. And I should be able to say c.speed equals something. Let's say I'll make it 50, right? So car's speed is now 50, kilometers per hour. Okay, what if I say c.speed equals 200? What I want it to do is say, no, you cannot go that fast. In other words, I want to make it so that if I try to set, so trying to set the speed less than 0 or greater than 100 should result in an error. And if you're in places where you can go more than 100 kilometers per hour on roads, even here in Israel, we're allowed to do that. I'm just trying to make the numbers easy, okay? Fine. So that should result in an error and an exception being called. So what are we going to do? This is a job for a descriptor. And true, we could use a property here, but I actually want you to use a descriptor in order to do that. So how's that going to work? Well, we're going to need a new class. I'm going to call this class speed. Okay. And so what's going to happen here? In my car class, we can say def init. We'll say self, and we'll just give it a name. Def init self, and we'll say name. Because, car's name is very important. Self.name equals name. And then I'll be able to say here, our, Kaya Forte. That's what we've got, folks. Practical cars here. All right. So what I want to be able to do is, now that I've got this car, I want to be able to set the speed. Well, the speed is going to need to be somewhere. So in order for this to work, the speed is going to have to be a class attribute, not an attribute on the instance. The moment it's on the instance, we're going to lose all the magic. So I'm going to say here, speed equals, and notice it's a class attribute, equals an instance of speed. See what I did there? So this speed class attribute is an instance of the speed class, which I defined up here. Well, actually, I haven't finished defining it. So when I say here, print c.speed, we should be able to see, should see it's 50. And let's see what happens now. All right, so how's this going to work? Well, if I just set it to be an integer, it would be pretty obvious. But if I set it to be an integer, then we wouldn't have these limits. If I set it to be a property, then we would have the getter and the setter that we could do things with. So what's going on here? Basically, this object is implementing the descriptor protocol. Descriptor. And so here's what we're going to do. We are going to define this object to have 3 methods. Well, actually, we can just use, init and then get and set. So I'm going to say def init. So I'm going to need that in a little bit. Self. And we're not taking any arguments right now. So we'll say here print in speed init. All right, so far so good. Every time we retrieve the value, every time we say print c.speed or use c.speed, then the get method is going to be invoked. Self. Okay, but wait, is it really just get there? No. It's going to be get, self, and then the object on which we're being invoked, and then object type, well, we're going to set that to be none. We're not going to use all these arguments, just so you know. Like, it can get a little complicated. So I'm going to say here print in speed get. And then we return whatever. Return 10. Doesn't really matter for now. And then def set self, and then object, and then new value. Print in speed set. So let's see what's going on here. And I'm going to ignore, well, actually 200 we can use still, right? So then print c.speed. So what's going to happen when we run all this code? Well, right now, when we actually create the car class, and when we're here on line 14 and we're defining the class attribute speed, we are also invoking the speed class, meaning we're going to get a new instance back. When we get a new instance back, init is being run, so we get init. So far, so good. Then, line 20, we're going to say c.speed equals 50. Normally, in usual Python, assigning to an attribute like that, c.speed equals 50, is just going to say, okay, c.speed, now you're looking at 50. But because c.speed implements the descriptor protocol, meaning because it has this dunder set method set on that object, it's going to capture our assignment, and it's going to run our method. Right now, our method does nothing other than print set. And then in speed, get. Okay, so what happens there? Well, because we implemented this dunder get method, when we ask for the value of c.speed, it doesn't just return the value that's referenced by c.speed. Rather, it's going to invoke the dunder get method. That's what happens. What does dunder get return? Returns 10, so that's what we get. Then we're going to set it again, and then we're going to get it again, and that's the end. This is obviously a really stupid way to do it, right? Because we're not actually setting or getting anything. So let's do some of that. So what I'm going to do here is inside of dunder init, I'm going to say self.speed equals, let's just call it 0. Now, why would I do this? Because I need to store it somewhere. And just like in all objects, I'm going to use init to set up the attributes that I'm going to need to use later. And then in get, I'm not going to return 10. I'm going to say return self under speed. And here I'm going to set it to be a new value. I'm going to say here self under speed equals new value. And now, if you look, things have actually improved. So we set it to 50, and we get 50. We set it to 200, we get 200. Pretty nifty. So basically what we've managed to do is take what we did with properties and move them aside into another class. And one of the advantages of using descriptors is that if you have a very similar property in many different classes, you can extract it from there and use that descriptor instead. It's basically doing the same thing. It's saying when I retrieve this object, I want to invoke a method. And when I set this object, I want to invoke a method. So there are a few things we still haven't done yet. One of them is we have to put in some limits. So I'm going to say here, class speed to, high error exception pass, and we'll say also speed to low error exception pass. And now what I can do is I can say min speed equals 0 and max speed, and we're ignoring reversing, okay, equals 100. And so now what I can do is in set I can say if new value is greater than speed max speed, then we're going to say raise speed to high error too fast. And similarly I can say if new value is less than speed min speed, we can say raise speed to low error too slow. And so now when I run all of this, see, I'm trying to set c.speed equals 200, and we're going to get an exception there. The exception is going to say you're trying to go too fast. Sure enough, if we go down here when it's executing, there we go, speed too high error. By the way, it's usually a really bad idea to use the built-in Python exceptions for this sort of thing. You really want to use your own exceptions. So far it looks great. So far it looks like we've basically managed to add some guardrails, appropriate for a car, I guess, add some guardrails to our car class. So all the issues of speed are now taken care of by our speed class, and we're doing great. There's only one little problem, which is what if I now say, let's do this. I'm going to say here C1 equals a car. We'll say, and we'll say C2 equals a car, and we'll say it's, I don't know, Toyota. And so I say C1.speed equals 50, and print C2.speed. Uh-oh. C2.speed is 50. Well, what if I say C2.speed equals 30, print C1.speed? Uh-oh. It turns out that because we have a class attribute there, all of the speeds are actually now sort of combined. So because we have this class attribute, so speed here is shared by all of our instances, which is a bit of a problem now. So what are we going to do about this? How can we deal with it? Well, here's what I can do. I can say, for example, I'm not going to set under speed here. Or even better, I can say, watch this, I'm going to say here, from collections, import default dict. And then self under speed equals a default dict of 0. Why would I do that? Because now I'm no longer going to put that underscore speed as an integer, because the integer was shared by all of our different cars. Not a good idea. We don't want all the cars to go and all the cars to stop at the same speed. That would be really bad, plus dangerous. And now when I say return self speed, I'm not going to return the entire default. Oh, I don't want 0 there. I want int. Sorry. Classic mistake. return self underscore speed. I'm not going to do that. I'm going to say instead, return self underscore speed of obj. That's right. We are getting there the instance of car on which this was invoked. That allows us to distinguish between our different cars. And now what I can do is I can say here, also when I set it, self speed on obj. And now it should all work fine. This is all going to work great. Oh, well, speed too high are fine. And then if I set this here, we're going to see that they have different speeds. And look, the default is 0. Why is it 0? Because I said to be a default dict, and in a default dictionary, it invokes the function if the key does not exist. And if the key does not exist, if the object isn't in there, then it's going to invoke the int function without any arguments. And what happens when you invoke int without any arguments? You get 0. Fantastic. So we are actually doing pretty well here. And now we have a much more robust version of our speed descriptor that we can use to both set and retrieve and keep it separate across our different objects.